I'm A. Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. Today we are going to discuss about structures in C programming language. So we are going to learn about what is a structure, what is the need of the structure, and the declaration of a structure, initialization of a structure, and accessing of structure members with sample examples. And coming to the structures. Structures, it is a derived data type. It is a collection of elements of heterogeneous data type, which means it's nothing but a collection of different data type elements. So it is a heterogeneous collection of elements of different data elements under a single name. See, coming to the arrays, we can store only similar data type elements, which means we can, in an array, we can store, if we declare int a of some 10, so only 10 integer values we can store. So suppose if you are declaring float a of some 5, then only 5 values that are of float data type values we can store in this particular array. If it is char, so we can store only the characters. So it is nothing. The disadvantages of this array is we cannot store different data type elements under a single name. So that can be overcome by using this structure. In this structure, we can store these complete student records. See, in this array, we can store only all student marks. But coming to this structures, we can store the complete student records like student name, student marks, student phone number, student address, all this such information we can store in this structures. So it is nothing but a collection of elements of different data type elements under a single name. Inside a single name, we are accessing all these elements, different data type elements. So declaration of a structure variable. The variable of a structure can be declared inside the main function or after the structure declaration. We can also declare inside the main, or else also we can declare the after the structure declaration. So this is the syntax of structure declaration. Struct. So struct name. So for whatever the new concept we are going to learn, we are discussing about the declaration and initialization concept. So for that we have some declaration syntax. So the syntax is, we are using this struct keyword to identify that this is a structure data type. And structure name is nothing but it is an identifier. So what type of structure you are pointing. And the next, in this structure, see here, opening the brackets, and we have written data type variable 1, data type variable 2, and so on. So a number of data members we can store in this structures. So the one data type variable is called as a member 1, and the second member is called as the member 2. So like this, what are the data type and variables that you are giving inside the structure? They are called as the members of that particular structure. So how many members you want to give? You can give that many members based on your task. And the next, inside the main function. So this is nothing but the variable declaration. So struct name and variables. So this is nothing but just a template that we are providing to the compiler that we are using a structure, and in this structure this data type we are using. So for that, if you want to declare, if you want to access the memory, or if you want to get allocation of the memory for the structure members, then we need to declare a variable to that particular structure. So if we declare a variable, then only the memory of this particular variables will get allocated. So for example, so struct a student. So this is a struct student. So struct is my structure name, and student is the name of that structure. And the next, char name of 50, which means for name we have some multiple characters. So that is the reason why we are using an array here. We might have some multiple characters. It's nothing but a string data type that we are using. And the next, int age is of integer type, and percentage is of a float type. So here we have some different data types and with of different identifier names. And the next, inside the main function, the structures is struct student. See here we have given the syntax as int struct name. So here struct is the keyword that we are using to identify that it is a structure. And the name of the structure is the student, and the variable that we are creating for that it is s1. So if I suppose if you are using like int a, int is a data type and a is a variable. So here the struct and the struct name together we are calling it as a structure name. Together we are calling it as a data type. So to this data type, we are creating a variable called S1. So the same thing that has been declared over here. Structure name and S1. S1 is nothing but the variable that we have created of this structure student. And whatever the data members you want to add, you can add, and at the end we need to close the structure by using a semicolon. So this is as per the syntax. So this is one way of declaration. So this structure declaration is common for every structure, but the variable declaration is different. So we can here see, we can declare inside the main function, and also after the declaration also, structure declaration also we can do it. So this is nothing but the inside the main function we are creating that structure variables. Now after the declaration, we'll check the syntax of that particular structure. So declaration of a structure variable. See here, the syntax is structure name. So this is after the this is after the structure declaration. So the variables we can also create after the structure declaration. So structure name, and these are the members, variable, data type variable 1, data type variable 2, and so on. So n number of variables you can declare. And after the end of this brackets, we are declaring the variables over here. Variable 1, variable 2, so on till variable n. So how many variables you want to declare? So that many variables you can declare. So consider the previous example. Say student, and the members that we are using is name, age, percentage. So name is of character data type, age is of integer data type, and percentage is of float data type. So different data type values you can store, and also similar data types also we can store. So here these are the variables that we're declaring, S1, S2, and so on till S1. So how many variables you want to declare, how many student record you want to store, you can store in this particular structures. And coming to the memory allocation. So whenever we declare a variable, then at that time memory will get allocated. So consider for S1, we have declared the variable as S1. So in this S1, the first member is char name. So which means the 50 bytes of memory will get allocated to store that particular name. So each character will be storing in 1 byte, as we studied in the data types concept. So here consider the starting address from 100, so 101. So consider the starting address from 101 and it ends in 150. So 50 bytes, right? So 101 to 150 bytes of the memory is used to store the name of that particular student. And the next here we have int age. The size of the integer data type is 4 bytes. So the continuous memory allocation will be happened here also in the structure concept. So after the name, the next 4 bytes starting from 151 to 152, 153 and 154. 4 bytes are used to store the age. In the next, we have a member as float data type, and to this float data type also the size of the float is 4 bytes. So 155 to 158. Again 4 bytes of memory is used to store the percentage of that particular student. So this is for S1. And similar, if you have created this S2, for S2 also same. This many bytes, like first and for name 50 bytes, and then for age 4 bytes, and then for percentage 4 bytes of memory will get occupied. So consider the memory started from 201 to 258. So for S2 also the same bytes of memory will get allocated for each and every variable in the structures. So here the total memory allocation for a member is, so 50 plus 4 plus 4, that is 58 bytes of memory will get allocated to store one single student record in the structure concept. So same as for S2 also, the other 58 bytes of memory will get allocated to store the second student records. So if you have declared many students, many variables, so at that time, so how many variables you have created, that many based on this data type, size of the data type, memory will get allocated. So now we have seen the structure declaration. So till now we have seen the structure declaration. Now we are going to see about the structure initialization. So how we can initialize the values to the structure. For suppose the data type is int a is equals to 10. So if it is int a, then we are telling it is a declaration. If you are giving this a is equals to 10, so at that time this is nothing but the initialization. We are giving values to that particular variables. So in the same way, we have seen the declaration of a structure and also the declaration of a structure variables. So now how we can initialize the values to that particular variables, we are going to see. So here same the syntax of this initialization structure is structure name, and same as the structure declaration, data type variable 1, data type variable 2, and so on. How many variables you want to give, how many members you want to give, you can give. And the next, inside the main function, the struct name variables and constant 1, constant 2, and so on. So how many variables you have given, so that many values you need to give. And the first value will be assigned to the first member of the structure. The second value will be assigned to the second member of the structure, and so on. So whatever the value you are giving in this place, so that value will be assigned to the member one. So coming to this example, this struct is the keyword that we are using, student is the structure name that we have given, and the next char name of 50 bytes, and here int age and float percentage. So three different data types we are using here, and inside the main function, see, we have given struct student s1. And to the student, we have given the ABC. ABC is nothing but the name of that particular student. So this value will be assigned to this name. So whenever we declare a variable, the memory will get allocated as we discussed in the previous slide. So it is, for suppose S1, it is allocating some, we have given 50. So 50 bytes of memory will get allocated. 50 bytes of memory will get allocated. And in this particular 50 bytes, A, B, and C, and the remaining all the next 46 47 bytes will be wasted. And the next again 21 is the value that we are storing inside the age. So this is used for name. These 50 bytes are used for name, and next 4 bytes are used to store the age, and next 4 bytes are used to store the percentage, each of 4 bytes and each 4 bytes, float and int having the same size. So again this 89.9 will be used to store this, 4 bytes are used to store this value, that particular value. So it is storing in, and these values are taking in a sequential order. The first value will be given to the first member, second value will be given to the second member, and third value will be given to the third member. And also we have some other declarations to the structure, that is, so we can also declare over here like struct name, and the next data type variable 1, data type variable 2, and so on. So we can also declare over here S1. S1 is equals to the values we can use, like, see, not S1, that is the syntax. So variable 1 is equals to constant 1, constant 2, and so on, based on the members. So the values we can also, the variables and the values to that variables we can also initialize after the structure declaration. So the example for that will be, so struct student, and the same example we'll take here, character name. So it has a capacity of 50 bytes, and the next is int age, and next is float percentage. And here we are giving us the variable name that we are initializing as S1, and equals to the values we are giving here it as ABC, that will be allocated to the name, and next age is 21, and the next float is 8, and the percentage is 89.8. And also if you want to initialize the values for the second variable also, so at that time you can use a comma over here, and the next you can give S2 is equals to, and the name will be XYZ, and the age will be some 80, and the percentage will be some 79.9. So, and after the completion of initialization, we need to end up it with the semicolon. So this structure declaration is also possible in our concept. And the next is how to access that particular structure members. So we are accessing that particular members by using a dot operator. So the members of these structures can be accessed with the help of a dot operator. This dot operator is also called as a member operator. If the structure variables are pointers, then the structure members can be accessed by using an arrow operator. It is also called as indirect selection operator. See, S1 dot name, S1 dot age, S1 dot percentage. If we take the previous example. So in the previous example, the structure, inside the structure, we have the members as name, age, and percentage. So by using with the help of the variable name and with the help of that member name, we can access that particular value. So here S1 dot name, we'll get the name of that student 1 name. And the next, if we are using S1 dot age, then we'll get the student 1 age. And S1 dot percentage is student 1 percentage, that value we can be accessing. And if it is for S2, if you are creating the second student record as with the name of variable name as S2. So at that time you can access the name by using S2 dot name, S2 dot age, and S2 dot percentage, and so on. So by using this dot operator, we can access that particular values that are present inside the structure. And the next one, simple programs, that is program to read and write the details of two students using a structure. So see here, we are using this stdio.h header file, and the struct student. Struct is the keyword that we are using, and student is the name of the structure that we are giving. So we are trying to store the student record, so that is the reason why we have given the structure name as the student here. Suppose if you are storing the employee details, then at that time you can change the number. And also we based on different tasks. For suppose if you want to store some book details, so at that time you can give the name of the structure as book, and the members might be some how many pages, or their price, edition. So all those, which edition of that particular book is having. So all those things that we can include inside the structure. And the next, inside the student structure, we are giving the first member as name, second as age, next as roll number. And here we have S1 and S2 are nothing but the variables that we are created for that particular structure. And the next, we are asking to enter in student details. And by using this scanf statement, we are reading that particular student details and storing in S1 dot name, address of S1 dot age, and address of S1 dot roll number. See, whenever the variable is created, the memory will get allocated to that particular variable. So if the memory got allocated, so that whatever we are reading by the user by using this scanf statement, that values we can store in that allocated memory. So we have learned about the accessing of structure members by using a dot operator, variable name and member name. So it is a string, that is the reason why we are not using any address operator. But for integer and float values, we need to use the address operator for sure. And the next printf, we are asking to enter two student details. So by using this second student details and by using this scanf, we are also reading that all that particular student details and storing in its respective allocated memories. And the next, by using this printf, we are printing that particular values. So we can get that values by using this s1 dot name, s1 dot age, and s1 dot roll number by using a dot operator. So all those statements will get printed, or whatever the student records you have given, that student records will get printed. So here two students records that we have given, so all the students records will get printed in the console. The next program is structure initialization example programs. So here we have given the header file, and here we have taken the structure name as employee, and the struct is the keyword, and this is the name of that particular student employee, and this is the employee ID, salary, and experience. So these are the members that we are going to add in this employee structure. And the next, to this struct employee, we are declaring the variables as E1, E2, E3. We can also declare it globally. So to this E1, we have given the name as Rahul. The Rahul will be assigned to this E1 dot name. Say for suppose. So whenever we have declared the variables for suppose E1, so the memory allocation is, so first 50 bytes is used to store name, and next we have the int data type. Next 4 bytes is used to store EMP ID, and the next float salary we have. So next the float data type size is also 4 bytes. So next 4 bytes is used to store salary. And the next experience also we have in the float data type. So for experience also we are using 4 bytes, and for experience also the memory got allocated is 4 bytes. So here we are taking E1 is equals to Rahul. So the Rahul will be stored in this allocated memory. So it takes only 1, 2, 3, 4, 5, 6 bytes. So 5 is the characters that we are using, and for a string we are using null character as the end of the character. So total 6 bytes we are using to store that particular name. And the next employee ID. So employee ID will be stored in this allocated memory. And the salary is 55.456 that we are storing in its allocated memory, and 6.7 is the experience that particular employee is having. So for same E2 also, E2 the value is Chaitanya, and the employee ID is 124, and the salary is this one 78,000, and the experience that particular person is having as 8.9 years of experience. So in this way the memory is allocated and the values are storing in that particular allocated memory, and we are printing those two employee details by using event.name. So by using dot operator, even dot name, if you give this even dot name, then the Rahul will get printed over here. So here this for a string we are using the percentile s as a control string. So the first value will be reflected in the place of this percentile s, and the second event.emp id will be reflected in second control string place, and event.eSalary will be reflected in the third control string place, and event.experience will be reflected in the fourth control string place. So all those values, whatever you have given, that values will get printed. So we also have some another initialization by using a dot operator also we can initialize it. For suppose if you are using this struct student, and the next inside the struct student we have int roll number, and the next char name of some 20 bytes, and the next float piece, sorry, marks. Consider these are the data types that we have inside the structure. By using dot operator also, not this one, by using a dot operator also we can initialize the values to that particular structure. So that is inside the main function int main, and here we are giving it as a struct student s1. Consider, so s1 dot roll number is equals to some 12. So in such a way also we can assign values, initialize values to that particular structure members. And the name, so to this name we are using the string copy function. So string copy, so whatever the name you have, that one you are assigning to s1 dot name. So consider my name is some abc. So string copy function we have seen. So that is, we'll have some two parameters. What is the string that we have in the second parameter, that will be copied to the first parameter. And the next float marks. So this float marks we can directly give it as s1 dot marks is equals to some 89.5. So this, in this way also the initialization can be possible. And again by using the printf statement we can print all the values, that is percentile d is used for roll number, and percentile s is used for name, and percentile f is used to give the marks, comma s1 dot roll number, comma s1 dot name, comma s1 dot marks. So such initialization is also possible. So initialization of values can be done in this way also. One is this one, we can directly give over here, and also we can directly give over here. Here also we can give that even is equals to, and all the values we can give in this flower brackets. So that is possible, this is possible, and this thing is also a possible, the structure initializations. Thank you.